Hi all. So in this video, I'm here to discuss about the topic on threshing. So we all may wonder what is the meaning of threshing. So let's have a look at it. So threshing is nothing but like we are separating the crop, that is the harvested crop from the field, into we are removing the grain separately, glooms, lima, palea and rachis. That is, we are separating it from the external pods. So as the wordings goes by, it is a process of loosening the edible part of cereal grain from the scalpy inedible chaff that surrounds it, and in simple terms, it is of removing the grain from the chaff and stems of cereal crops. So this process of repeated pounding and dragging, we call it as the plant mass over a surface or the aperture. So simultaneously here what happens is that the operation detaching the grains from the spikes, panicles, ear heads, cobs or the pods. And it is basically done by striking or by trading or rupturing the crop. So main principle behind this is it is mainly achieved by three methods. One is the rubbing, another one impact force and the stripping. So threshing is normally done after when the grain moisture content is reduced to 15 to 17%. So in the picture you can see that is these are a few the methods how the threshing is being done. So based on this, the main principle behind threshing is based on the principle when the impact is given to the crops, the grains will get separated from the outer cap. Rupture of the bond between grains and the ears is mainly due to the impact or the rubbing action, and the strength of the bond between grains and the panicles. This mainly depends upon the type of crop, variety of crop and the moisture content and the ripening phase of the crop. So and last one is the efficiency and the quality of threshing. This will depend upon the many threshers, mechanical threshers like drum speed, number of beaters used in the drum, quality, direction of feeding and the rate of feeding. So this is in the picture you can see how traditionally the threshing methods are done. First one is by the hand beating. Hand beating methods are normally used for threshing rice that easily shatters. The output obtained by this is nearly 17 to 20 kg per hour. So this is also like by using another method in traditional ways by using bullock. So bullock is the one of the indigenous method in bullock trading, is in which the crop is spread on the threshing floor in a circle and the bullocks are made to walk on the circular path so that the grains get separated, and maximum we will obtain 140 kg per hour. Main disadvantages of this type of traditional method is that it will give a very slow method. Output is also low, and due to low output the cost operation is high, and there is a huge loss of grains because of the rodent attack, birds, insects, and ultimately due to the climatic changes and the fire hazards. And mainly keeping that in mind, there are many mechanical threshers being used. So those components are concave, threshing cylinders and the cleaning units. So coming to the concave type of thresher, where the concave shaped metal grating partly surrounding the cylinder against the rubbing cylinder rubs the grain from the plant or ear heads, and through which the grains fall on the sieve. So what happens is that due to the concave surface the grains get separated. Threshing cylinder, this is one of the most important component of thresher, so comparing to the other concave one. So here they have spikes on the periphery and their support for threshing the crop. There are many types of threshing cylinder: peg tooth, wire loop, brass bar, angle and hammer. So in this picture you can see the types of tooth being used with the different types for the threshing cylinder. And peg tooth, coming to the peg tooth, the teeth on the concave and the cylinder are so arranged that the cylinder teeth pass midway between the staggered teeth on the concave, and the clearance between the cylinder and the concave is adjusted according to the requirement of the grains we use, and as the stacks pass through the clearance space, the grains get separated from the head due to the impact force. Wire loop is in such cylinder is studded with a number of wire loops throughout its outer periphery, mostly used on the paddy thresher. This type of thresher is being used in paddy thresher. Angle bar, you can see like they have rubber pads on their faces, and mainly this type of cylinder is equipped with the angle iron bars that is helically fitted on the cylinder. So here the clearance between these two is 13 to 19 mm, and which can be reduced to 6 to 9 mm also. And in hammer mill type, you can see there are many beaters are in the shape of hammer mill. The beaters are attached with the beater arm at the tip, and these beater arms are rigidly fixed to a hub which is mounted on a main shaft. And next is a rasp bar cylinder. This has corrugated bars around it, and here this type of threshing is done between the corrugated cylinder bars and stationary bars of the concave. So whereas here usually 8 to 6 bars are spirally fixed on the cylinder. And last one is the cleaning unit. Cleaning unit function is to separate and clean the threshed grain. Mainly consists of the two or more oscillating sieves, a fan and a sucking duct known as the aspirator. Usually two ducts, the primary and the secondary duct here acts. Function of the primary is to remove the major portion of straw, dust and the other foreign matters, whereas secondary will help in the final cleaning of the grain. So this is the thresher with the aspirator. This is just a schematic diagram of thresher where the threshing drum is there, a blower and a shaft is also attached, and concave cylinder is also being fixed in the threshing drum. Air duct for the flow of grains without any breakage, and the screen. So how the threshing efficiency now it can be calculated for a thresher is that the threshed grain received from all the outlets with respect to the total grain input. So how much we are giving input and how much we are getting into from the outlet, so from which the efficiency can be calculated in 100% of the unthreshed grain, where factors affecting this threshing efficiency is that due to the peripheral speed of the cylinder concave clearance, type of crop, the crop that we use for threshing, moisture content and the feed rate, efficiency will differ. And cleaning efficiency can be calculated by quantity of clean grain obtained from the sample taken at main grain outlet by total quantity of the sample that we used for threshing into 100. And last one, this is something about like combined harvester thresher. So this machine is mainly designed for harvesting, threshing and also separating and cleaning and collecting the grains while moving through the standing crop. Standing crop itself, we can use this type of combined harvester thresher, whereas it will harvest and also it will thresh the crops and give. That's what its function is, to cut the standing crop, feed the crop to threshing unit, thresh the crops, clean the grains from straw. At last it will collect the threshed grains in a container. So this is the picture of a combined harvester thresher. Whereas from the, you can see right side from the field it is been harvesting and it goes to the thresher part and grains the threshed here and comes out of the thresher. So this is something about a small topic on threshing. Thank you.